In this video, we are going to go over the use case of continuously sending frames using the data streamer in MCC Melody. At the end of this use case, we'll be plotting a number of placeholder count variables, and we'll also show you how to measure the length of time it takes to send a frame. I have an empty MCC Melody project, and I'm going to be adding the data streamer. As I add it, you can see that there's some configuration which needs to be done, and I'm going to open the context help to see how to do this. Here you can see that there's a choice between the AVR and PIC API references, so you'll just choose whatever you are using. What we're going to end up with is basically this picture here, a number of different variables. So we'll set up the variables like this, some different variable types, just basically placeholders, which will be replaced by your own application variables, maybe an ADC reading or something like that. So we're using a Curiosity Nano. It gets recognized by your computer. You're going to have debug GPIO or a COM port, and specifically I'm going to be using the latest version here. And you can see that we now have the variables represented in a structure which has the same name as the API prefix. Scrolling down to the first use case. So add data streamer to your project and check your board schematic to see which UART is connected to the debugger. So this particular board is recognized as COM28 from the computer side. But what we need is to consult our kit schematics to see which UART is connected to the embedded debugger, which in turn is connected to the computer. UART 3 is our dependency, and now we'll just set up these different variables. So just checking back with the instructions now, check the TX-RX pin configuration, generate the code, add the code snippets. Okay, your dependency selection, so we set up the variables as we've just done. LED pin as output and name it LED. So at the UART level, yes, there's nothing there. Pin grid view, we can just double check. So PB0 is TX, PB0 is TX, and PB1 is RX. So by default we happen to have the right pin configuration, and port B3 was our LED pin. And here we just use the LED to blink after sending a frame. Okay, so that should be good. We should be able to generate code now. Okay, so data streamer.h, delay header if needed, and you can see in this example, we send a frame and then we can add a delay. So DS frame update, and then main we can just copy over directly because we're not doing anything in main yet. Okay, so you can see that data streamer, named data streamer as per the API prefix, and clicking on the data streamer struct, we can see the variable setup as we configured. The send flag frame is now part of the header file code snippet. We'll now add a delay to slow down the sending frames. For AVR, that's going to be util delay. So here at the end we can add a delay of maybe 100 milliseconds. So we build successfully, and we can now program. So coming in here, what we're going to do is under our COM port, click on this new variable streamer and import. So now under generated files, data streamer, there'll be a DS file. And that just tells the data visualizer what variables have been set up. New access per data type is a good default since it groups variables of a similar size. And now we can remove some of the other lines. Okay, now what we can do to check the frequency here is add another plot. And here we're going to add debug GPIO. Okay, so we can zoom in and add a couple of cursors. And yeah, so you can see about 118, maybe a little bit less, 110. For example, to understand what's happening here, we could go back to our code, and when we send the frame here to set this to true in the routine, we can say LED. We could use LED set low to turn the LED on since it's active low, and set high to turn it off. Okay, so same thing now. And see these different variables incrementing, zooming in again and pausing. Here we can see that about 10 or 11 milliseconds is actually used to send the frame from our code. So that's not insignificant, though some of our variable types are quite big and we are sending quite a number of bytes. That's why we're not directly sending the frame. We are rather just letting that happen in the while loop when we're not doing anything else.